Hello and welcome back to my channel, students. In this problem series which is based on general organic chemistry, we have already covered some 24 problems and let us now see the problem number 25. As you can see the problem on your screen, you have a compound in front of you which carries 4 nitrogens marked as A, B, C and D. You have to tell a decreasing order of basicity of these nitrogens, and for that you should remember that basicity of nitrogen is based on the availability of lone pair on nitrogen, the availability of electrons on nitrogen. More the electron density on nitrogen, more will be its tendency to give electron, and therefore higher will be its basicity. Basicity is related with the tendency of an atom to provide electrons. So on that basis we have to see a hierarchy. Now for that to be checked, I have spoken a lot about this. The lone pair should remain localized on the nitrogen. It should not go away from one place to another. It should not be in conjugation, because if it comes in conjugation, the availability of electron becomes less and therefore the basicity becomes less. So what you should keep in your mind, for a better basicity, for a higher basicity, the localization of lone pair on nitrogen is very important, and higher the extent of conjugation of the concerned lone pair, more will be the delocalization, more number of atoms it will spread on, and therefore the availability on the nitrogen will decrease even more, and therefore it will be very less basic. So that should remain your point of view while deciding the basicity of nitrogen. So we will take up all the cases one by one and will think about the availability and conjugation. Now starting with the A option, nitrogen number A, you can simply see that the lone pair on nitrogen number A are in conjugation, is in conjugation. How? You can see that lone pair, single, double, single, double, single, double, single, double, single, double. So what does it mean? It means that the lone pair on nitrogen A is going to get delocalized in both the benzene rings. In both the rings it is going to get delocalized, and therefore the availability of electrons on nitrogen number A will be badly affected. It will decrease because there are many resonating structures you can draw where the lone pair you won't see on nitrogen but on some different atoms. So the availability of electrons on nitrogen number A is going to decrease, and therefore its basicity also going to decrease. Now let us try to see what happens with the nitrogen number B. If you try to see the electron pair, the lone pair on nitrogen number B, you find that this lone pair is not in conjugation. How? Once you try to see the conjugation situation, you won't find that. How? Lone pair, single, single. And this is not a condition for resonance, it is not a condition for conjugation. So you remain assured that this lone pair on B is going to remain localized and is good for the basicity of nitrogen, because more it has the electrons, higher will be its tendency to give, and therefore basicity will be higher. Now coming on to the lone pair on C, nitrogen number C, as you can see the lone pair on C is very similar to lone pair on A in terms of the conjugation. How? You can see that the lone pair is again in conjugation with both the rings. How? Lone pair, single, double, single, double, single, double, single, double, single, double. You understand, because of this alternation of single and double, there will be an extended conjugation, and because of this extended conjugation, the lone pair will hop on many atoms. And if you can do that, if you can draw many resonating structures, the availability of electron pair on the nitrogen number C will be badly affected. It will be very less, and on that basis you can say that the basicity is less. Now the similar thing was happening with A also. Then how you are going to compare between A and C? You remember that in A and C, the common thing is, in both cases the lone pair was getting delocalized in both the rings. However, in the case of C, there is one more avenue, there is one more way in which the lone pair gets delocalized, and that is the one of the prominent way, and that I have drawn in this figure, as you can see. Now while you can see this figure, you can figure out how it is happening. You understand, once the lone pair goes like this pi bond shifts like this pi bond can be shifted like this because of conjugation. Simultaneously this will go like this will go like this, and this will go like this, because again there is a conjugation, double, single, double, and this double will sit on oxygen, and that structure I have drawn, as you can see on your screen. This is the structure which is a prominent structure, because here the minus charge. In other structures the minus was borne by the carbon. Carbon is less electronegative. On the other hand, oxygen is more electronegative and is more capable of holding the minus charge, and that is why you see a clear cut difference between the nitrogen A and nitrogen C, because in nitrogen C you have one more atom to share the lone pair, and that is not a simple atom but a very powerful oxygen which will hold the minus charge, bear the minus charge with very ease, because it is electronegative element. And this feature was absent in the case of A. Therefore in the case of C, the delocalization will be more, and therefore the availability of electrons on the nitrogen C is lesser than on nitrogen number A. So that should remain your point of view while differentiating between A and C. Now coming on to the nitrogen number D. Again you find that the lone pair on nitrogen number D is localized because there is no conjugation for resonance to happen. How? You can see lone pair, single, single, and this lone pair single, single is not a condition for resonance. Had it been lone pair single, double, then it was a condition of conjugation, resonance, and delocalization would have happened. But in the present case, lone pair single, single is no means by which this lone pair can get delocalized. So it will remain localized on D. Now once you come to this conclusion about D, you get a confusion. There is a confusion which is then more basic, B or D. Why? Because in both the cases B and D, the lone pair is not in conjugation and remaining on the nitrogen itself. Then how to decide which is a better base, whether it is B or D? For that to happen, you have to see the next slide, which I have created a difference. Now in this slide you can see that once this you understand, this is C double bond O, and this double bond is in conjugation with the pi system of both the rings. How? You can see double, single, double, single, double, single, double, single, double, and so on. Because of this conjugation, you can draw this resonating structure which I have drawn. And what is the use? Let me tell you. Once you find this conjugation, you do the resonance. You shift the pi bond on this oxygen. This pi is going to shift here. This is going to go there in an alternate fashion. This is going to shift there. This is going to shift this position. And once it does this, this carbon loses electron and here a plus charge comes, as you can see. So because of the C double bond O, a conjugation is there, and that conjugation brings a plus charge right at this carbon. And because of this plus charge, you understand the electrons will be pulled through the sigma bonds toward this carbon bearing plus charge, and the electron availability on B will get reduced because of the pulling power of the plus charge. However, the similar type of plus charge will not come on this carbon. How? You can continue the conjugation from that point, plus single double. So if double shifts like this, the plus will come here, and once you see plus single double, the double shifts like this and plus will come here. So what I try to say, because of this C double bond O, the plus will come just at this carbon but not at this carbon. So the thing what I am trying to say, the pulling power of the carbon bearing plus charge will affect more the nitrogen number B in comparison to nitrogen number D. Why? Because the plus charge is coming close to nitrogen number B, and therefore it pulls the electron harder. On the other hand, it does not come that close to nitrogen number D because of the plus charge hopping from one neighbor to another neighbor without coming to this particular door. So you should understand the plus charge will not bring that problem which it brings to nitrogen number B. So on that ground, you can say that the availability on D will be higher than the availability on B. So after taking every point into consideration, you can finally say that, let me finally list all the features and we'll compare finally. This lone pair is getting delocalized in the two rings A. B, the lone pair is localized because of lack of conjugation. It will not get delocalized. However, it is less available because I have already explained in the previous slide that because of the conjugation of C double bond O, a plus charge will come right there and it will pull electrons, and because of that the availability will be lesser. If you talk about C, again the lone pair is going to delocalize in both the rings, and apart from these two rings, the lone pair will sit on this oxygen also, and you have more ways to delocalize the electrons in case of C in comparison to A. So higher the delocalization, lower the basicity. And now coming on the on D, nitrogen number D, you understand the lone pair is remaining delocalized and highest available. Why? Because the plus charge even not comes at this carbon, on this carbon, and therefore there is no withdrawal that takes place as it takes place in the case of B. So if you take all the points into consideration, you can write a final hierarchy. The highest availability is with D, then will come the B, and then will come the A, and the least available is C. So this is going to remain the basicity order based on availability of electrons. So I hope you all must have got the fundamentals, the logic behind the availability and how to check that availability. I hope you all must be watching my videos carefully and must be getting information, must be getting the concepts, and I will keep on making such type of videos in future also. So till then, keep watching my video, keep studying, and take a good care of your health and happiness. Thank you very much.